In this video, I will explain wave propagation in conducting medium. Wave propagation. Wave propagation in conducting or lossy medium. Consider Maxwell's equation. First equation, del cross H bar is equal to J bar plus dou d bar by dou t. J is equal to sigma E bar. D is equal to epsilon bar by dt. That is equal to sigma E bar epsilon dou E bar by dou t. This is the del cross H bar. Differentiate our equation with respect to t. That is dou by dou t. Del cross H bar is equal to sigma dou E bar by dou t. Epsilon dou by dou t of dou E bar by dou t. That is dou square E bar by dou t square. Here rewritten this equation. Del cross dou H bar by dou t is equal to sigma dou E bar by dou t plus epsilon dou square E bar by dou t square. This is equation 1. Consider another Maxwell equation. Differential form. Del cross E is equal to minus dou B bar by dou t. B is equal to, since B is equal to mu H minus dou mu H by dou t. That is equal to del equal to minus mu dou H bar by dou t. Dou H bar by dou t. Taking curl of this equation. Taking curl of this equation. Del cross E bar is equal to minus mu del cross dou H bar by dou t. Dou H bar by dou t. This equation can be written as del dot E bar minus del square E. This is the formula. A cross B cross C is equal to A cross C dot B and A into B dot C and A into B dot C, like that. In that by using that expression, that is equal to minus mu del cross dou H by dou t. This is the equation number 2. Substitute del cross dou H by dou t is equal to sigma dou E bar by dou T plus sigma dou square E by dou T square. Substitute first equation in that equation, in second equation, minus mu into del cross dou H by dou T is equal to sigma dou E bar by dou T plus epsilon dou square E bar by dou T square. From that expression here, one more important expression is del cross del square E bar is equal to del square E bar is equal to minus del square E bar is equal to minus mu sigma dou E bar by dou T plus epsilon dou square E bar by dou T square. Bring this del under bracket del dot E bar is equal to, bring this side here, E bar like that. Del square E is equal to minus are cancel here. Mu sigma dou E bar by dou T epsilon dou square E bar by dou T square del of del dot E. We know that del dot D bar is equal to rho V. Del dot epsilon E is equal to rho V. Del dot E is equal to rho V by epsilon. Rho V by epsilon. There is no charge within a conductor. It may be there on the surface of the charge density. That means rho V is equal to 0 for lossy conductor, lossless conductor. Lossy, not lossless, lossy conductor. Rho V is equal to 0. Del square is equal to mu E bar is equal to mu sigma dou E bar by dou T plus mu epsilon dou square E bar by dou T square. Similarly, in case of electric field, similarly in case of magnetic field, not electric field, del square H bar is equal to mu sigma dou H bar by dou T plus mu epsilon dou square H bar by dou T square. These are the two equations. This is the equation. This is the wave equation for conducting medium in terms of H. This is the wave equation. For conducting media. For conducting medium in terms of H. In terms of H. Consider one equation here, del square H E bar, del square E bar is equal to mu sigma dou E bar by dou T mu epsilon dou square E bar by dou T square. Phasor form, we use phasor form, phasor representation. E bar is equal to real term of E power E into E power j omega t. This is the phasor form of electric field. Phasor form of phasor form. Del square E bar is equal to mu sigma dou by dou t. E bar is equal to real of E power E into E power j omega t plus mu epsilon dou by dou t of real of E power j omega t. That is equal to mu sigma dou by dou t E into E power j omega t real plus mu epsilon dou by dou t real of dou by dou t E power j omega t. That is equal to mu sigma real of E power E dou by dou t of E power j omega t is E into E power j omega t mu epsilon dou by dou t. That is E derivative of E power j omega t is j omega, not omega t. That is real E into E power j omega t. That is j omega. Mu sigma real of E power E into E power j omega t is E bar plus mu epsilon real of dou by dou t of E power j omega t into j omega. Mu sigma E bar mu sigma into j omega is also there. J omega plus mu epsilon E into E power j omega t j omega into j omega. That is equal to mu sigma j omega E bar j omega plus j omega whole square mu epsilon real of E power j omega t is real of E power j omega t is E bar. That is equal to del square E bar is equal to here j omega mu sigma E bar minus omega square mu epsilon E bar. Omega square mu epsilon E bar. Common term is j omega mu. Omega mu is common term. Suppose j omega mu is common term. Sigma Here minus sign, we need another j into j square, j square minus, that is minus. One omega is common term, another omega is there, that is mu is common term, epsilon e bar, epsilon e bar. That is equal to gamma square. Let it be gamma square j omega mu sigma plus j omega epsilon. Gamma is equal to square root of j omega mu sigma plus j omega mu into sigma plus j omega epsilon. Here gamma is called as the propagation constant. Gamma is called as propagation constant. Propagation constant. Propagation constant is gamma is equal to alpha plus j beta, where alpha is called as called as alpha is called as the attenuation constant. Attenuation constant. The wave is propagated through that conducting media. Some attenuation is there. That attenuation is represented in terms of alpha. That is attenuation constant. The unit is a dB per meter. Beta is called as phase constant. Beta is called as phase constant. Radians per meter. Radians per meter. Therefore, delta square E bar is equal to gamma square E bar. Gamma square E bar. This is the conducting media equation in terms of electric field vector. Attenuation constant, generally attenuation constant alpha dB per meter, it is defined as a constant which indicates the rate at which the wave amplitude reduces as it propagated from one point to another. It is the real part of the propagation constant. It is the real part of the propagation constant. The derivations of alpha, derivation of alpha and beta. It is a gamma is equal to alpha plus j beta. Alpha is attenuation constant. Beta is the gamma is propagation constant. Beta is called as a phase constant. Phase constant. Gamma square is equal to, we know that j omega mu sigma plus j omega epsilon gamma square. Gamma square is equal to alpha plus j beta. Alpha plus j beta. First of all, you need to calculate alpha plus j beta whole square, gamma square. Alpha square, a square, a plus b whole square minus plus jb whole square. J square is minus, it is alpha square minus beta square plus 2j alpha beta. Alpha square minus beta square is equal to, here gamma square is equal to, here alpha square minus beta square is 2j alpha beta. Gamma square is here gamma square j omega mu sigma j into j square minus omega square epsilon mu. This is one is real term. This one is imaginary term. This one is real term. This one is the imaginary term. Compare these two. Therefore, alpha square minus beta square is equal to minus omega square epsilon mu. 2 alpha beta is equal to omega mu sigma. Omega mu sigma. From that expression, we have to calculate alpha square plus beta square. Alpha square minus beta square whole square plus 4 alpha square beta square. That is alpha power 4 plus beta power 4 minus 2 alpha square beta square. That is equal to this entire term can be alpha square plus beta square can be written as this in this form. We know that alpha square minus beta square is equal to minus omega square epsilon mu minus whole square, that is plus. Therefore, omega square mu epsilon whole square 4 alpha square beta square. Here 2 alpha beta square on both sides. That is 4 alpha square beta square is equal to omega square mu square sigma square. That is omega mu sigma whole square. That is alpha square plus beta square. Alpha square plus beta square value here is omega square mu sigma whole square common term 1 plus omega mu sigma by omega square mu epsilon whole square. Mu cancel, omega one time cancel. That is equal to omega mu epsilon into square root of 1 plus sigma by mu epsilon whole square. This is the alpha square plus beta square. Alpha square plus beta square. But alpha square minus beta square is equal to minus omega square epsilon mu. Alpha square minus beta square is equal to minus omega square mu epsilon. One time add these two equations. That is equal to adding 2 alpha square is equal to here omega square. 2 alpha square is equal to omega square mu epsilon into square root of 1 plus sigma by omega epsilon whole square minus omega square mu epsilon minus omega square mu epsilon. That is equal to 2 alpha square is equal to omega square mu epsilon is the common term. Square root of 1 plus sigma by omega epsilon whole square minus 1. Alpha square is equal to omega square mu epsilon by 2 into square root of 1 plus sigma by omega epsilon whole square minus 1. Therefore, alpha is equal to omega square root of mu epsilon by 2 total whole square here. Square root of 1 plus sigma by omega epsilon whole square minus 1. Minus 1. This is the alpha. Coming to beta. Here alpha square plus beta square, alpha square minus beta square, both are added. But we will get a beta value. Both are subtracted. Therefore, finally, beta is equal to here instead of -1, here we use +1. Mu square root of mu epsilon by 2 square root of 1 plus sigma by omega epsilon whole square minus 1, like that, minus 1. This is the attenuation alpha is called as a attenuation constant. Attenuation constant. Beta is called as a phase constant. Beta is called as phase constant. Beta is called as a phase constant. And the characteristic impedance, one more derivation is for a uniform plane wave traveling in z direction, for a uniform plane wave traveling in z direction in the lossy media. In the lossy media. Therefore, we know that dou square E by dou square E by the expression is here is del square E bar is equal to gamma square E bar. The wave is uniform wave is traveling z direction in lossy media. Here dou square E bar by dou z square is equal to gamma square E bar. Here del is equal to dou by dou x plus dou by dou y plus dou by dou z. E bar is ex plus ay ez az, like that. Dou square means in case of wave is traveling in z direction, dou by dou x, dou by plus dou by dou y is 0. Finally, dou by dou z is there. Dou by dou z is present. Okay. This is the equation. One solution for the above equation is one solution of above equation. One solution of above equation is E bar z is equal to E naught bar e power minus gamma z. In case of convert this into time varying field, E bar z comma t, phasor representation is converted in time varying field. Real term of E bar E naught bar e power minus gamma z is multiplied with e power j omega t. Multiplied with the above equation with e power j omega t. That is the reason E bar z comma t converts phasor form into time varying fields. real of E naught bar or E naught. This one is E naught amplitude of the electric field component. E power minus gamma z e power j omega t. E power j omega t, that is equal to real of E naught e power gamma z. E power gamma is alpha plus j beta z e power j omega t. That is real of E naught e power minus alpha z into e power minus j e power minus j beta z e power j omega t. That is equal to real of here e power minus alpha z bring outside real of e naught e power j is common term omega t minus beta z omega t minus j. This is the equation of EM wave propagating in z direction and attenuated by a factor e power minus alpha z. This is the equation of EM waves. Equation of EM wave propagated. This is the equation of EM wave propagated in z direction z direction and attenuated by a factor and attenuated by a factor e power minus alpha z. This is the wave. Attenuation is z direction. Z is equal to 0. This is the amplitude of that electric field component. Like that. The variation is like that. This is the wave propagation in summary of propagation of characteristics of EM wave in conducting media. First one is propagation constant. Summary. First one is propagation constant. Propagation constant gamma is equal to gamma square. Gamma is equal to, we know that, square root of j omega mu sigma plus j omega epsilon. J omega epsilon. Second one is unit is 1 by m. Phase shift constant. One is phase shift constant beta. Alpha gamma is equal to alpha plus j beta, where beta is called as a phase shift constant. Beta is equal to omega square root of mu epsilon by 2, mu epsilon by 2, square root of 1 plus sigma square omega square epsilon square plus 1 plus 1. This is one type. Radians per meter. Third one is attenuation constant. Attenuation constant. Attenuation constant, that is equal to alpha alpha is equal to omega square root of mu epsilon by 2 square root of 1 plus sigma square by omega square epsilon square minus 1 alpha. Velocity of propagation of EM wave in a conducting media. Velocity of propagation of EM wave. Propagation of EM wave. EM wave is equal to V is equal to omega by beta. E is equal to omega by beta. That is omega by beta is from second equation 1 by square root of mu epsilon by mu epsilon by 2 square root of 1 plus sigma square omega square epsilon square plus 1. One is the entire one. And lambda is equal to 2 pi by beta. Lambda is equal to 2 pi by V is equal to F lambda. Omega is equal to 2 pi F by beta. F cancel, therefore lambda is equal to 2 pi by beta. Therefore lambda is equal to beta. We know that beta propagation constant 2 pi by beta value. Beta is omega. Omega is 2 pi of square root of mu epsilon by 2 square root of 1 plus sigma square omega square epsilon square plus 1 2 pi is cancelled. That is lambda. One more important parameter is by using Maxwell's equation, derive that intrinsic impedance. Intrinsic impedance is the ratio of E by H. That is E by H is equal to square root of j omega mu by sigma plus j omega epsilon ohms. These are the summary of propagation characteristics of waves in a conducting media. This is the summary of propagation characteristics of EM waves in a conducting media. This is derivations are completed.